Just when I thought I'd mastered all the different methods of procrastination available to me, I find a new one. Making YouTube videos. It's holiday season at the moment, so while there aren't many people around, I'm going to give you a lab tour. Different kinds of biology labs are classified according to the types of microorganisms being researched in them. And the microorganisms are further categorized into risk groups according to how dangerous they are, that is, how likely they are to infect a person with a disease. There are 4 different kinds of risk groups which are pretty much the same across all countries. The risk groups take into effect things like how likely the organism is to give someone a disease, the mode in which the disease might spread, and how easily we can treat the disease. So the lowest risk group is risk group 1, and that's some sort of organism that's probably not going to give anyone a disease at all. Step up from that is risk group 2. This is something that might give you a disease, but it's something we can treat pretty easily. It's not going to spread, so it's not really much to worry about. Risk group 3 is like, that's a disease you're probably not okay with, but we can treat it and it's probably not going to spread fast, so you'll manage. Risk group 4 are the kind of things they like making movies about. I mean, get that stuff on yourself and you're gone along with everyone you know. It's the stuff where they say things like, we can't treat that, please be more careful with those vials. So the labs are classified as either a PC 1, 2, 3 or 4 facility. This one is a PC2. PC stands for physical containment. This refers to the kind of setup the lab has in order to stop anyone getting infected with any sort of disease and spreading it, depending on the kind of microorganisms you're working with. So this kind of setup you see here is like a PC1 setup. All the work can be done on benches without any fume hoods needed. Basically, all the organisms you're working with are usually dead or only parts of cells, which are pretty harmless. You're not going to catch anything in here. This kind of room is more of a PC2 setup. So we've actually got cells living in incubators in here, and you've got fume hoods that you work with the cells in here. You could potentially get some sort of infection from these things, but probably nothing much worse than you pick up from anyone else on the street. I've never been in a PC3 or 4 facility, and to be honest, I'm not sure I want to. This is the Dirks room.
Wait, what?
It's basically this is the cool room. Why? What did I say? The cool room is basically just a large walk-in fridge. We use it for storing bulk amounts of material and sometimes for running reactions overnight that need to be kept at low temperatures. These boxes are the incubators where we keep our cells while they grow. They're capable of monitoring and controlling the temperature, so they're at 37 degrees Celsius, and also the level of carbon dioxide and oxygen that's in here. Because it's holidays and there aren't many people here, there aren't many cells in here at the moment, but these ones are mine. This is a centrifuge. A centrifuge is a machine that contains a spinning rotor, and on this spinning rotor there are spaces to put vials or tubes. Take a tube that has liquid in it, and usually it also has cells or bits of cells floating as a suspension in it, though this one is just water. And you put it in the machine, and you turn it on, and it spins around and causes all of the cells or bits of cells to sink to the bottom in a tight clump, and then you can suck off all the liquid on the top and add a different liquid. That's the point of the centrifuge. Centrifuges come in all different sizes. This is a cute little one that has space for 24 different Eppendorf tubes, which are these cute little guys. This little guy holds 8. And this cute little guy, called Sprout, only holds 6. He's a little broken. And now for a tour of the chemistry lab. This machine here is called a rotary evaporator. Now, one of the reasons chemists hate this machine is that anytime someone from the media wants to come in and take a photo of us standing in the lab to put next to an article about our work, they will always take a photo of us standing next to this thing. The rotary evaporator, or rotevap for short, has several parts. What it's used for is taking a compound dissolved in a solution and boiling off the solvent at low pressures in order to obtain pure solid compound. The flask with your compound dissolved in a solution is immersed in a water bath, usually set at about 40 degrees Celsius, and there's a vacuum attached to it which pulls a vacuum on the whole system, lowering the pressure so that the solvent boils off at lower temperatures. So at 40 degrees Celsius you can remove solvents that would usually only boil at much higher temperatures. So the solvents boil out of the flask, move through the glassware and end up here. In here is a glass coil through which is run a liquid that is kept at a low temperature, and it causes all the solvent vapors to condense and collect into this flask here, which you can then throw in the waste. A lucky organic chemistry lab has this machine here, which is an automated way of doing column chromatography. The manual version looks like this. Column chromatography is a method for separating materials to purify your compound. It's kind of complicated, so I'm not going to go into it here. Organic chemistry labs don't really have many machines in them. Everything we do here is done pretty manually. The machines we do use regularly are much larger, much more expensive, and generally are kept in their own facilities somewhere else in the building. Okay, I think that's enough show and tell for today. If you don't mind, I have work to do. Yeah, you're not meant to get it, that's the point. If you think I'm doing this for anyone's entertainment except my own, you are grossly mistaken.